All right, so we're talking about graphing linear inequalities. So if you have something like y is less than or equal to 2x plus 5. Okay, so first of all, when you graph an inequality, you should pretend that it is just an equation. So y is equal to 2x plus 5, right? And then you graph that line. So I'm going to go and graph that line. I start at 5, right, because that's my y-intercept, and then my slope is 2 over 1, so rise 2, run 1, basically run 1, rise 2, right? So here are the points. All right, so that's just from this equation here, but I'm not really graphing the equation. I'm graphing the inequality. So getting those points help me knowing where the line would be, but now I have to go back and look at this. Now, is this less than or equal to, or it's just less than, right? So if there's an equal sign, that means it's a solid line across, right? So you have a solid line. That means that every point on this line is part of the solution, okay? So point on the line is part of the solution. Now I have to check a point. So after graphing that line, I check a point. So I pick a point not on the line. So you can pick any point, right? You can pick like -5 and 5, or -6 and -2, but those points are hard. Which point should I pick that is really easy, that is not on the line? 0, 0, right? 0, 0 is a nice point. So I put 0 in for y. So I check point 0, 0, okay? And then I put 0 in for x to see if it works, okay? So I have 0 is less than or equal to 2 times 0 is 0 plus 5. 0 is less than or equal to 5. Is that true? No. So it doesn't work. So this point is not part of the solution. So I know that the other side is part of the solution. Okay, so if you check a point and if it doesn't work, the other side will work. And if it does work, then that whole entire side will work. Does that make sense? Okay, so I tested this side, it doesn't work. I know I have to take the other side. That's always the case. Okay, so everything on this side will work. Okay, everything on this side, including points on the line, will work. Okay, so what are the possible solutions? Possible solution could be x is equal to, let's see, I can say x is equal to, I'm going to take this point. X is -3, y is 3. Right? Or if x is at -1, then y has to be like at 4 or 5 or 6, right? X is equal to -1, y is equal to 4. Or x is equal to -1, y is equal to 5. Any of those points will work. Any point in this region will work. Okay, that's part of the solution. Anything over here is not part of the solution. Okay, we're going to try another. All right, so here I have this equation now. It's in standard form. Oh no, it shouldn't be equal, right? It should be less than 6. There you go. So here I have to convert that to slope-intercept form to graph because that's the easiest way to do it. So I subtract 2x from both sides. I have y is less than -2x plus 6. So here I pretend that it's like an equation. And then I graph that. I start at 6. And the slope is -2. So I go down, to the right? Down 2, right 1, down 2, right 1, and so on and so forth. All right. So now I know my line goes that way. Then I go back. I'm done with that. I go back and I look. Is there an equal sign with it? No, there's no equal sign. So it has to be a dashed line. Okay. That means that the points on the line are not part of the solution. Okay. Only the points on one side or the other will be part of the solution. So I'm going to check. You can check any point you want. Okay, as long as it's not on the line, you can check it. Usually you should check 0, 0. But I'm just going to do 1, 1. I want to check 1, 1. Just to show that that also works. Okay, so I'm going to check 1, 1. I have 1 for y. And I'm put 1 in for x. So 1 is less than negative 2 plus 6. 1 is less than 4. Is that true? No, that's not true. So this point doesn't work. That means none of these points will work. That means that everything on the other side will work. Okay? So if they want a possible solution, you just pick a random point. This point is a solution. This point is a solution. Anything over here is a solution. Okay? Anything over here is a solution. Anything over there. Okay? How about that equation or inequality? All right, so you want to do this one. You want to subtract 2x from both sides. So I have y is larger than negative 2x. Okay, now let's pretend that that's an equation. I have x-intercept is 0, so I start here. Slope is negative 2, so I go down 2 over 1, down 2 over 1, down 2 over 1, this way. Okay, I'm doing this a little bit fast because I'm assuming you guys can graph lines already. Okay, all right, I got the outline of my line. I know it's going to be there. Now I'm going to have to check a point. Well, actually, I have to see if it's a solid line or dashed line, right? There is no equal here, so it's a dashed line. All right, now I want to check a point. So normally you want to check 0, 0, but in this case, can you do that? No, right? Because 0, 0 is on the line, so I can't check 0, 0. I'm going to check, 1, 1 is probably the next nicest point. I'm going to check negative 3, 1. Just to show you how that works, okay? So I put 1 in for y and negative 3 in for x. 1 larger than 6, is that true? No. So this point does not work, right? So I have to take the other side. Okay. If I checked point 1, 1, it should have worked, okay? So I have 1 for y and 1 for x. You see how 1 is larger than negative 2? That works. So if I check this point 1, 1 here, it works. So I take that side. So if you check a point, if it works, you take that side. If it doesn't work, you take the other side. Okay.